In this video, we're going to take a more detailed look at the data frame, the fundamental unit in the pandas Python library. It's an incredibly useful structure which, when grasped fully, proves a great asset for data manipulation and analysis. Let's dive in. For tables with many rows, a Jupyter notebook typically shows the first 5, the last 5, and then hides everything in between. However, with Python, in Jupyter and outside of it, there is a pandas method that we can use to manually limit row output, head. By appending .head to the end of a data frame object, output is limited to the top 5 rows. We can modify that number by placing an int in the brackets for the method. Sorting is done using the sortValues method. The by parameter allows us to specify the column by which we want the rows ordered. By default, it sorts in ascending order according to the column specified. To sort it in descending order, we set the parameter ascending equal to false, like so. Filtering, or subsetting, is a feature of pandas data frames which regularly comes in handy. It allows us to return subsets of a data frame such that we can see only those rows and columns containing the values that we are interested in. Filtering takes place in square brackets placed immediately after a data frame object. We'll call these the selection brackets. There are different ways of using the selection brackets to filter by either columns or rows. For columns, as we have seen before, we can specify one or more column names in these selection brackets to see a subset of the columns in the data frame. A single column name goes on its own, but 2 or more column names must be in the form of a list, in square brackets, inside these selection brackets. In order to see a subset of rows, we place a conditional expression in these selection brackets. Take note here that we usually need to repeat the name of the data frame object in the conditional expression itself. The expression we place here actually returns a pandas series object, a one-dimensional array containing true and false values. True where a row did satisfy the condition, false where it didn't. So a series of trues and falses in the selection brackets tells pandas which rows in the data frame we wish to see. We can also string useful methods onto the conditional expression. Here, I want to see all those rows in the dataset for which the age column has a value, or is not blank. So my conditional expression says df age, which is a series of all the values in the age column, and then checks each one for being not NA, or not blank, and returns true if it is not blank, and false if it isn't. Creating columns is a simple process, which we do using the same selection brackets after the data frame object and providing the new name of a column in string format inside them. A common use for this method is to create a column based on a mathematical transformation of one or more others. So we might want to multiply age with the fare paid for a ticket on the Titanic, and would then set the new column declaration equal to df age times df fare. Keep in mind that this calculation works because the result has the same number of rows as the original dataset. We would get an error if we set our new column equal to something with a different number of rows. There are various ways we could set the new column to be filled with specific values, like zeros. Here, we use the numpy zeros method to create a column of zeros. Deleting rows or columns is as simple as using the drop method on a data frame object. We need to specify 2 things: a single column name or a list of multiple column names which we want dropped, and the axis value. So here we set axis equal to 1, which tells the method to look amongst the columns for the names that we have specified that it should drop. It's just as simple to delete rows. In that case, we need to specify indexes rather than column names. Remember, indexes are the labels of the rows. And we also set axis equal to 0 to make sure the drop method knows which dimension to remove from. Remember, the axes of a data frame are as follows. So 0 means rows and 1 means columns. If you forget, always remember Roman Catholic. Always Roman first for rows and then Catholic second for columns. The last trick we'll look at is the group by method attached to a data frame object. In the group by method, we specify the column or columns that we wish to create groups from. So for each unique value in that column, a group is made. So in the P class column in this dataset, we have 3 unique values, 1, 2, and 3, and each group gets its own row in a new data frame. Aggregating like this is largely useless unless we actually ask something of each of the groups. So common things being the mean, the sum, the max, or the min. So here we string the mean method onto the end of the group by method, and the result is that for each of the 3 groups, we get a mean value for each of the numeric columns in the data frame. Non-numeric columns are ignored in the case of numeric methods. So that should give you a far tighter grasp of how to use pandas, a useful library in the life of any Python-wielding data scientist. Be sure to go through the notebook accompanying this video for some further detail and a few exercises with which you can test your knowledge. All the best, and we will see you in the next one.